Hello and welcome. In this video, we'll be looking at recurrence relationships and relations. In Okay, so what are the recurrence relations? When you have a recurrence relation, the next term of a series is defined as a function of the previous term. So this means that the next term on the left here is a function of previous term, un, or the current term. Okay, so for an example, next term of a sequence is given by the current term plus 4. You do always get given the very first term of a sequence to substitute into the formula. So in our case, we've been asked to find the first four terms of this sequence, and also another one. We deal with part B in a minute, but let's just substitute and find the numbers for part A. So 7 plus 4 makes an 11. The first term is 11. Then, well, the second term is an 11 because the first term is 7. So we write 7, 11, and then 11 plus 4 is 15, and 15 plus 4 is 19. Simple, isn't it? So, do you want to have a go at part B and then check your answers with me? Yeah. Okay, I hope you've had a go. So, when you substitute 5 into this formula here, you will have the second term to be 5 plus 4. So if we write 5 comma 9, and 9 plus 4 again gives us 13, and 13 plus 4 again will give us 17. It's quite simple, isn't it? But don't be fooled, they're not always so simple. Just remember, with recurrence relations, you need to know the relationship and also the starting value. So, have a look at this problem, have a go at it, and then compare your answer with me. Alright, so the first term we already know is a 2. To get to the second term, u2 is 2 times 2 plus 3, which is 7. So we would put a comma on 7. The third term would be 2 times 7 plus 3. 14 plus 3 is 17. The fourth term would be 2 times 17 plus 3. So that's 34 plus 3, that makes 37. And the fifth term would be 2 times 37 plus 3. So that would be 74 plus 3, which is 77. Alright, so you would get 2 as the first term as it was given to us, then 7, 17, 37, and 77. Note that this is neither a geometric nor an arithmetic sequence. Okay, the next term is just some function of the previous term. You cannot, if you want to, you need to have to add them separately if you had to add them up. Alright, let's look at the next example. We've been told that the first term is p, and the next term is the current term squared minus 1. Of course, n goes from 1 up. Alright, we have been also told that p is a negative value, but for now, we just to show that the third term will have this algebraic equation. So first we need to know the second term. We know that the first term is a1 is p. What is a2? a2 would be a1 squared, so that would be p squared minus 1. Then the third term would be whatever the second term is, squared minus 1. What is the second term? Second term is here. So I'm gonna write p squared minus 1 in a bracket and take away 1. When you expand the bracket, what do you get? You would get p squared times p squared. So p to the power of 4 minus 2 lots of p squared plus 1 minus 1. Of course, this plus 1 and minus 1 cancel. That's why we're going to get this expression here. Alright, so let's look at the next part of the question. Alright, these are the values that we found in the part A. So in part B of this question, we've been told that given that A2, the second term is 0, find the value for P. So that means we need to substitute this A2, this formula, and equate it to 0, solve for P. When that's equals to 0, add 1 to both sides of the equation and take the square root. Now, which value of P would you take? P can be either 1 or minus 1, but because here we were told that P is negative, we actually going to say P is minus 1 and discard the other answer. This factor here would tell us P is 1. This factor would tell us P is minus 1. We would discard this answer. Let's look at the next part. The next part of the same question, we've been asked to calculate the sum of the first 200 terms of this sequence, given that A1 is a negative 1 and the A2, we were told A2 was 0. Alright, so when we substitute 0 into this formula, what would A3 be? A3 would be minus 1 again. And when we substitute minus 1 into this equation, just like we did with A1, what would we get? Minus 1 squared would be plus 1, plus 1 minus 1 would give us 0. So A4 would be 0. Do you get the pattern? We started with minus 1, 0, minus 1, 0. So it's just flip-flopping between minus 1 and 0. So you don't have to work very hard. If you write them in a neat line, what you notice is that you will have from 1 to 200, you would have a hundred of these terms to be negative 1. And if you're adding them up, what do you get? You would get simply minus 100 because the other 100 are zeros. Okay? So let's look at the part B of this problem. It's saying what's the value of 199th term? 199th term is odd. I would match it with any of these odd indices. It would be minus 1. Okay? So happy practicing. I'll see you in the next video.